So they take this data they have and begin to draw insights from that data, and they look at it and look at what inferences they can be able to get from this data. So using statistics or using data visualization, they can be able to do that. And during inferential statistics and descriptive statistics, they can be able to get more insight from the data they have. Then next you have the data scientist. So what data scientist does is they tend to build machine learning models that can be able to predict or forecast the based on the data they have fed into the model. So that's where the part of machine learning comes in. So what machine learning does is that, like I've said earlier, that it can be once you pass in data, it can be able to learn from that data, and it can be able to make predictions from the data you have fed it in. So that's the job of a data scientist. So the data scientist have to incur the abilities for him to use maths and statistics, data preprocessing, and yes, machine learning, of course. So with all this stuff he has, he can now be able to apply them and be able to. So once they pass in data, he can now be able to predict those stuff he has based on those data he have. Then next you have the machine learning engineer. So that catchphrase is so common, at least, yeah, machine learning engineers. So what basically machine learning engineers does is just the deployment side of things, and that's where the domain expertise comes in. So the domain expertise, like take for instance, after the data scientist has finished building his or her model, so he now pass that model to the machine learning engineer. So the machine learning engineer is the one that deploys it on the server. So like take for instance, now you want to do a speech recognition, you want to build a speech recognition model. So after the data scientist has finished building the model doesn't just stay there on the computer just like that. So it's the job of the machine learning engineer to take that model that he has built and deploy either either using either using some tools like Django or Flask, or Google like Firebase and Microsoft Azure and some other Google Cloud platforms also. So that's just what data science is in a nutshell, although it's still more broader than that. Next slide. Yeah. So machine learning. So that's where I'll be laying most of my emphasis on the machine learning side of things. So machine learning is it's in various forms, but it just depends on what you actually want to do. It depends on the problem you are trying to solve, that you would know the kind of algorithms to use, you will know the approach to take, and some other things you would want to do. So machine learning is actually grouped into three. You have the supervised learning, you have the reinforcement learning, and you have the unsupervised learning. So let me just explain what supervised learning is. Supervised learning is a form of machine learning whereby you are trying to predict something that has labels. Let's say take for instance now, you see a dog. So a dog in this case now is our label. So what are those attributes that those dog have? So a dog will have four legs, a dog will have whiskers, a dog will have a black nose, of course, and a dog will have some other features. So those values now can like be represented as the X, that's like the X of the dog, and the label that that dog has is actually a Y. So take for instance, I want to predict what kind of breed is this particular dog like. So what I just do is I take those attributes that those dogs have, like okay, this dog has this dog has this, then definitely is a Rottweiler. This dog has this dog has that, this dog has this, then definitely it's a German Shepherd. So supervised learning is a way that deals with data that has particular labels. So let's take another example now. Let's say I want to predict price. I want to predict the stock price of maybe in the next 5 days or in the next 6 days. So definitely, what I'm trying to predict in this case now is price. So price in this case is my label. So there are other attributes that conform price, that affects price. Let's say sales. Let's say the open stock, the closed stock, and some other stuff like that. So that is what supervised learning is. Is a form of machine learning that deals with labels. If you have labeled data, so another form again is you have the classification. Like under supervised learning, you have classification and you have regression. So classification is a way of, and that's what we are going to do today. A small project that we're going to work on. A small project that we're going to work on. Hello, can everybody hear me? Hello.
Yes, we
Yeah,
can hear
we can hear you.
you.
Just proceed.
Oh, okay. I just wanted to be sure. Okay, so we have classification. So classification is a form of prediction that deals with there's something in statistics we call discrete and continuous variables or discrete and continuous data. So let's say you want to predict like spam or not spam. For us that receive mails a lot, find out that there are some mails we get that it's in our spam folder, and there are some mails we get that it's not in our spam folder. So that kind of form is classification. It's a way of like, okay, this is spam or not spam, or this person will actually leave the company or stay in the company. So it's a way of classification, just like classifying something. Okay, how will I know which dog is German Shepherd? How will I know which dog is a Rottweiler? So it does that form of machine learning is it deals with form of discrete data. So discrete in the sense that it's fixed, it's not continuous. Like let's say regression, that you can be having a value of, let's say, 2.5, 2.7, 2.8 minus 1.7. But classification is discrete. It's either it's a 0 or it's a 1. It's either it's a yes or it's a no. It's either it's a true or it's a false, right? So it's fixed, it's discrete, right? And there are many algorithms you use for classification. So you have the naive Bayesian, you have the k-nearest neighbor, decision tree, and even neural networks, standard vector machine known as SVM, and you have random forest, and you have a lot of algorithms you can also do on classification. So that's for classification. For it's not that price is not fixed, right? Let's say I want to predict the price of rice in the next 10 years. That's a regression problem because I can't be having a price of 12,000 fixed. It's either it's a, let's say, 12,000, let's say 12,000.55 or 11 points something something. So it's continuous, right? So let's say it depends on the problem you are trying to solve. You know what kind of algorithms to apply. So for regression, you have like the logistic regression, and I think that's the most common form of regression. We've been taught that in most in our secondary school or universities. It's a very simple form of regression. Then you have like the stepwise regression, polynomial regression, ridge regression, linear regression. Yeah, the logistic regression and the linear regression, those two, they are quite common. And also to most of all these algorithms that we even use, like the random forest and the decision trees, they also perform some form of regression also. Yeah, and so reinforcement learning. Reinforcement learning is a way of learning that it deals with a way that machines learn as they are rewarded. So let's say, take for instance now, someone is asked to perform a particular task or a particular stuff, for instance. So as he's performing that task, he's being rewarded. Then as he's being rewarded, he has the ability to learn more, and he has the ability to be able to learn more from that data. So when he is not rewarded, he knows why he's not being rewarded, and he tries to learn from it. And this is always done in mostly in game development. And yeah, I think Google has done something on that using reinforcement learning, whereby it's bit layer, something to do with reinforcement learning. Is the way machines actually learn, and as they learn, they are being rewarded, and as they are being rewarded, they try to learn more. And if they are not being rewarded, they try to learn why they are not being rewarded, and they try to improve. So it's even much more broader than that. But let me just leave it there. Yes, and the other form, which is also common, is unsupervised learning. In fact, the most common form of machine learning used in a place like this today, in most countries like this today, is mostly supervised and unsupervised. So in unsupervised learning, you have the clustering, density estimation, dimensionality reduction. So let me explain clustering. So let's say, take for instance, now you have different range of customers in your organization, and you want to know the patterns some customers have. Let's say you deal with a kind of business that deals with purchase, for instance, and you find out that, okay, you want to segment or you want to group those customers you have into clusters. Like you want to know the patterns some customers exhibit, or you want to know some particular things you see a set of customers do. So instead of looking at data one by one, you can employ the form of unsupervised learning. And you notice that in unsupervised learning, you have no labels. You are not trying to predict anything. What you're just trying to look for is patterns you can be able to see in your data that you have. So that's where what clustering does. So like I said before, let's say you are trying to say that, okay, maybe this customer at the end of the month, they always buy this, they always buy that, they always purchase, they always purchase that. And you find out that this other set of customers, they are quick spenders, this other set of customers. That means when you've already built that model, if you pass in a user, it can automatically segment or cluster that user into a particular cluster. It can group that user to a particular cluster based on the machine learning model that you have built. So that's what clustering does. Now, yeah, and there are also algorithms you can use for clustering, such as the K-means clustering, the DB scan, the hierarchical clustering, wave cluster, and self-organizing map, and also Gaussian mixture. So yeah, and another one too you have is also density estimation. Yeah, density estimation is kind of like broad, so I don't think I'll really go into that one, but it's just like the same thing, so still looking for patterns. But the one I know really quite well is dimensionality reduction. So let me explain dimensionality reduction. So take for instance now, you have, like I said before, you have your X and you have your Y. Let's say in your X, for instance, oh, sorry, let me go back. So let's say in your X, for instance, have some attributes that connotes Y. So let's say you want to predict scenario should I use now? Okay, let's say you want to predict the price of something. We know that sales will affect price. We know that weather could be a factor that could affect the price. So we know that there are some other things again like electricity. We know some other things like data. There are so many factors that can affect price. So what we want to do is that if we are passing all that factors into that model for us to predict price, those values they are very they are much, so that when you pass them to your data, you find out that you have something called redundancy, and your values of your X are too much, and you find out that your machine learning model cannot be able to perform very well as you are training. So there's something you call dimensionality reduction. So dimensionality reduction is just a way of reducing your values of X such in a way that if you are trying to also predict Y, you will have a very still good accuracy that when you pass all those values into your data for you to make prediction. So dimensionality reduction is very powerful and is almost used. In fact, it is very used in companies today in such a way that they don't want to pass in all their features into the model. They try to do some kind of dimensionality reduction, reduce the kind of features they have so that they can be able to reduce overfitting and they can be able to have a very good accuracy. So that's what dimensionality reduction does. So that is just a brief intro of machine learning, and that's what machine learning can be able to do. And we know that all this is a form of machines being able to learn from data. So does anybody has anything, or can I go on? Hello?
Well, at the moment, there are no questions yet. So once the questions are coming in,
Okay.
you can drop your questions in the chat area. If you have, you can just drop the questions in the chat area if you have a question.
Okay, no problem. Yeah, so most people have always asked why Python? Can't I use yeah, and again, so machine learning comprises of many languages. You could write your machine learning models in R, you write your machine learning models in Python, you could write your machine learning models in Java, you could even write your machine learning models with MATLAB, even Excel, some particular forms of prediction, maybe regression or something. But most people ask that why Python? Why can't I use R? But for beginners, I would always suggest you should always start with Python. Python is very easy. It's very powerful. Like Python is easy to use, powerful, versatile, makes it a great choice for beginners and experts alike. Python readability makes it a great programming language, allows you to think like a programmer and not waste time with complex syntax. So yeah, so that is one of the issue why I would like to suggest Python. Python is very, very simple, and it's as if you are just reading a book. That's how I'll mostly see Python as. Python is not so thoroughly complex as other programming language. And again, Python is very, very robust. Like I'll give a case scenario. Like there was a time where I was given a project to, I was asked to build a model and I was asked to deploy that model. So data I had with me was very large. So I had to use a Python library, which was pandas and numpy to do my data preprocessing, right? I did not use Excel, I did not use MATLAB, it was still Python. Then after doing my data preprocessing, I used Python to actually use the machine learning models that were there. So it was still Python again. After building my machine learning models and after doing my data preprocessing and my data visualization, I still used Python. I did not use any other framework or any other library. It was still Python, right? So after building my models, I was asked to deploy. I know commonly most people use PHP, most people use JavaScript to deploy that using Node.js. But with Python too, you could also deploy your models to a server, yes, to production. Even in most companies, that's another form of machine learning called MLOps. That's machine learning operations. So I also used Python. That's by using Django. I was also able to also deploy that model that was given, and it was able to work fine. So I used one language for all those processes because Python is very, very powerful. So I never had to like rely on any other language to deploy. So I didn't have to learn any other syntax if I want to build machine learning models or if I want to process my data or if I want to deploy anything. So Python is very powerful, and there are a lot and lot of frameworks that you could actually use that will aid you in learning machine learning itself. So for someone who is starting or someone who wants to learn, I would advise the person to actually start with Python. Python is very, very easy and it's very, very straightforward. It's very, very simple. Right. So now that we've seen those stuff, so let us look at some machine learning applications. So like I said before, actually that machine learning is broad. So we have the supervised, the unsupervised, and the reinforcement learning. So these things are applicable, not that you're actually learning these algorithms, but you could actually use these algorithms to actually solve a lot of problems. And that is what data scientists are doing today. We'll be looking at how we can use machine learning in health and how data science and are actually playing a role in actually solving the problem, the ongoing problem going on in the world today, and that's in the COVID-19 issue. So how is data science actually solving a problem? So that's what we'll look at today. So let me just briefly explain this. So in the supervised learning, like I told you, we have the classification, we have the regression, right? So in the classification, you could actually solve a problem like identity fraud detection. Like fraud detection in banking, they could actually make use of machine learning to detect fraud. Another one again to is image classification, which is almost common. It's very, very common in most of, in fact, even in our phones today, we can be able to build an algorithm that can be able to tell you that okay, this is this person, this is not this person by using classification. And also something again is customer retention and diagnostics. That's in health. So we could use machine learning to even diagnose cancer. That's maybe in the nearest future, though, but we could actually use machine learning to actually diagnose. We use it for customer retention. And you could even use it for so much more. It's even more than this, even object detection, even predicting categorization. You could use it in so many things. In fact, just not just only these cases alone. And also in regression, you could use it for advertising popularity prediction. You can use it to forecast the weather. You can use it to forecast markets. You can even use it to estimate life expectancy, whether if someone will actually live up to 80 years old or 90 or maybe 120. So you could even use it for population growth prediction, right? So that's what you can use regression for. And again, yeah, in the unsupervised learning, like I told us before, dimensionality reduction. So let's say big data visualization. So for instance, if you have a very large data set and you want to visualize it, So if you are going to visualize it, you would definitely fall into maybe a runtime error, or the features are too much. So you could actually use unsupervised learning, which is dimensionality reduction, to reduce the amount of features that you have for you to be able to draw more insights in your data. And again, too, is also meaningful compression. That is, you want to compress, like just like the same thing as dimensionality reduction. You can use it for meaningful compression, structure discovery, and feature elicitation. So another one again of clustering, yeah, it's recommender systems. Yeah, recommender systems is just like a way of, just like what Netflix does. So when you are watching a movie on Netflix, you watch a particular movie. So there's a machine learning algorithm that runs at the back end. So when you watch a movie and you watch another movie and you watch another movie probably. So what the machine learning algorithm does is that it tries to fit you in a cluster, like it puts you in a particular category of where you fall in. So definitely, if it wants to recommend another movie for you, maybe you are the type that you watch sci-fi movies like me. So if you watch science fiction movies a lot, so it cannot recommend a horror movie for you. It cannot recommend a, although there are some cases whereby it will do that, but that's why that's a form of machine learning. That's why we have to do something called accuracy. So it recommends other movies similar to those movies you are watching, because it has put you in a particular cluster of where you belong. So that's one thing about unsupervised learning. And another thing too is customer segmentation. Yeah, like I've explained earlier, like where does this particular customer belong? Where does that particular customer belong? That's what customer segmentation does. And again, it's also targeted marketing. So let's say, take for instance, I'm able to cluster customers, or maybe I want to push adverts to some particular set of people. If I know that you can't be able to use your phone once a day, I can't be able to push target ads to you, right? So because you fit in a particular people for us push this ad to you, and you can be able to see it. So with the aid of machine learning clustering, it helps us in a way of knowing who our customers are, and knowing how we can even place target marketing to them based on the fact that we know the category of where they belong. So I think this explains the fact of most of the applications. And again, this is reinforcement learning. I forgot that. Yeah, so reinforcement learning, like I said before, is just a way of letting machines to be able to learn, and as they learn, they are being rewarded for what they do. And if they don't get rewarded for what they do, they try to see how they can improve on what they are trying to do. And where these things can be applied is in game AI, skill acquisition, learning tasks, robot navigation, and in real-time decisions. That is where reinforcement learning is being applied in, right? So, yeah, so after we've looked at this so far, we will try to see where does machine learning actually helps in healthcare. So machine learning helps a lot in healthcare, and research are being made day to day on how we could actually improve, and how we can actually help and try to solve a lot of problems in healthcare. So machine learning plays a role in healthcare in areas such as imaging and diagnosis of human disease, clinical trials and research, better radiotherapy, and outbreak prediction. So machine learning actually could help in areas like this. Yeah. So how does in role of what's going on today, we've been able to see like what's going on in the world today now, the COVID-19 pandemic. Hello, someone was saying so. So we we want to see how does data science actually plays a role in the COVID-19 pandemic. So far, like we've been able to see what's going on, and we've been able to see how data science can really help us. So from the little we've seen so far, and for those that actually follow what's going on, we can able to see that some people have been able to build interactive dashboards, which gives us an insight about the spread, and we've been able to build machine learning models to help project future spreads. So let me show you a bit of an example. Yeah. So this is example of like a dashboard that displays the cases, the deaths, and recovered patients of the COVID-19 pandemic. So let me show you. Yep. Yeah. So the thing is, this is an example of a dashboard of how helps us predict. Let's say, take for instance today, as at um, as at April 3rd, we've been able to confirm over 1 million cases. I've been able to see 811,000 cases active, and we've been able to see that okay, some people have been able to recover, and we've been able to see deaths. So why? So data science have been able to help us to give us an insight of how this disease is actually spreading. The insights we could be able to draw, we can be able to see that data science gives us this ability for us to see. That's with the help of data scientists, they can be able to help us and give us this insight. So take a look at distance now, the trajectory of cases around the world today. You can be able to see Greece, you can be able to see USA. I think USA is the one topping, USA is the one topping, yeah, the cases going on in the world today. And why I even like this dashboard, that like there are so many dashboards you see out there, but why I like this dashboard, because this dashboard was actually built with Python, and an interactive framework called Plotly. So Plotly is a way of is a framework of yeah, it's a framework built on D3JS. Although there's a Python library which you can use to plot. Plotly has a yeah, there's a Python library for that, where you can actually build interactive plots. So interactive plots in the sense that we have like two types of plots. We have like statics, we have the dynamic. So these kind of plots are dynamic and they are very responsive in the sense that when you try to hover your mouse over them, they are being responsive, right? So this can be able to the analysis you can be able to draw apart from what is going on in the world today is so much that data science has been able to give us a glimpse of what we can be able to see and how we can be able to know what's going on in the world right now concerning the coronavirus, right? So this is one of the major applications, at least the little we can be able to see so far, of where data science can actually help us in healthcare today. So let's play around with this stuff a little. So yeah, um, yeah, let me do a little bit of the active cases. Let me see that. Yeah, so you can see so far, Italy is the one leading deaths as at April 3rd with over 14,000 deaths. Then for Spain, Spain is the next. Then France, then US. Yeah, US has over 4,757 cases. Then China, then Germany, then South Korea, right? So let's see who has recovered so far. Wow. So we actually see China. China has actually gotten a higher number of recovered cases so far as at April 3rd. They've been able to recover over 70,000 patients. That's good. Then Spain, then Italy. Italy has recorded some cases. Um, then USA has over 9,000 people who has recovered so far from the pandemic. And that's actually good because I actually view this dashboard actually every day because I want to like know what's going on in the world right now. So as at in Nigeria, we've had sorry, yeah, good. Okay. So sorry, that information I gave you guys was actually the information that happened on the third, that's on March, sorry. Because why I like this dashboard is because you could actually go back to times of let's say as at even when the coronavirus actually started, like let's say period like around this time. So like around the 1st of January, where they were able to record so far 2,000 cases. So as we begin to move forward, so far you can see the graph. So far, China was the one actually having the highest number of cases. Then kept increasing. Then yeah, as at February, wow. Then they had 70,000 cases as at when as at 16th of February they had over 70,000 cases. Then kept declining, kept declining. Then another country rose again. That was South Korea. So South Korea was actually the second um, country to actually record a case of coronavirus. That's as at February. Then I think it started spreading to Italy. Then Italy now started recording another case. That's a higher number of cases of over 1,000, 1,128 cases. Then if we keep moving on and moving on and moving on and moving on, we'll be able to see where the world is right now. So far, this is the current situation of what is going on now. So we've been able to see US are they are the one leading um, the number of cases of what is going on in the world right now. The USA has recorded over 275,000 cases as at previous week. So, this is what data science can actually do and how it can actually help us in seeing with data, like seeing what is actually going on in the world right now. So data science is not even only applied in just healthcare, right? But we are laying more emphasis on healthcare. But data science is broad in itself that you could actually, even in healthcare, we could actually see and we could actually know and we could actually even project, and that's what I'm going to talk about next. We could actually project what is going to happen in the nearest future with machine learning because all this data that we are gathering and all this data we are drawing analysis from and we are visualizing, we can be able to see that data science can actually show us, can actually give us a picture of even what is going on in the world right now, even apart from even news. Because when we see data, we can even be able to draw some inferences from those data that we have, right? So this is a graph of like over 1,000 cases upwards. So starting from 1,000. So that's why Nigeria is not here. Let me look for it. So as at okay, so we have over 210 cases. Then Cameroon has 509 cases. Then Ghana, Cote d'Ivoire, so Benin has 16, Togo has 40. So it's kind of like spreading all throughout Africa. South Africa, wow, I think that they are the one leading in Africa now, like 1,505 total cases so far they've been able to get. So this is like a dashboard, a simple dashboard that explains everything. This dashboard was built with Python. You can see produced with Plotly. So it was built with Python and Dash. So Dash is another library from Python that you can use to create beautiful dashboards like this. Yeah. So this was what I wanted to explain. Right. So yeah. So this is like a simple dashboard displaying the cases, deaths, and recovered patients in COVID-19 pandemic. So another case whereby machine learning is actually playing a good role in healthcare is forecasting. We know that with machine learning, we can be able to predict into the future and we can be able to tell if China has 50,000 cases now, in the next 3 to 4 days or 5 days, what will be the number of cases they will likely have? So there's a competition going on online on Kaggle on forecasting the COVID-19 spread, right? So this is another form of data science and most especially machine learning. So machine learning is actually played a very good and crucial role in terms of forecasting. So let me show us. Um, yeah, this is it. So this is it here. So this is a challenge on Kaggle that data scientists, at least over 575 data scientists have teams have enrolled, and they are actually working on building models. So with this data that they have, although this data they have is not sufficient enough because the major issue about building machine learning models is having data, right? So this is a form of how data scientists or how machine learning engineers or how data analysts or people who do data stuff in general can actually play a role in healthcare. So this is a very good way that we see machine learning roles and we can see how people are actually doing a lot in actually building models and actually forecasting and actually doing some beautiful and amazing stuff with data using machine learning. Okay. Right. So now, yeah, so far we've seen capabilities of machine learning. So now let us build a simple machine learning model. I know that most of us are I'm trying to look at it from the beginner, the intermediate, and the expert level. So that's why I try to explain what data science and machine learning is in a nutshell. So I'm going to be building a simple machine learning model. So for this webinar, I'll be building a multi-classification model that predicts the diabetic type of a patient, either type 1, type 2, or normal. We would have done something similar to the coronavirus, but we don't have sufficient data, and the data that it's there, it's not really enough. When I checked, it was just the dates they gave, country affected, and it's just like 3 to 4 rows, 3 to 4 columns rather of features given, and that data is not enough to actually do something with. So it's the those data scientists that will definitely know what to do with data, maybe sourcing for other form of data that could actually help them in getting a very good and robust models so far. So with what we've done, so now we are actually going to the practical aspect of things. So before we actually dive in, does anyone has anything to say? Let me just look at that. So does anyone has anything to say so far?
No questions so far, sir.
No question. Okay, that's good. So I can continue.
Yeah, right on, sir.
Any
Okay.
question? Okay.
Any question? Because we're actually going to the code side of things now.
Okay. No one has dropped any question now, but we encourage you to drop your
Any
questions in the
question?
chat area. All right. You can proceed.
So yeah. So like I said before, we'll be building a simple machine learning model. So I'll give you, so after this, after the end of this webinar, I'll be giving you the notebook and the necessary links you can use. So I want you to actually have a glimpse of what machine learning can actually do and how we can actually use machine learning to actually solve problems. So I'll work with you on, I'll show you how can build a simple machine learning model. So this is the model I'm trying to build now is a diabetes prediction model that predicts the type of diabetics the person have. So like I told us before, uh, it's Python and Jupyter Notebook. Yeah, this is Python and Jupyter Notebook that I'm using. So like I've said before, that Python is actually very robust and Python is actually very good and very broad. So this pandas is my data preprocessing library. Data preprocessing library. So NumPy is actually used for mathematical operations. So what pandas could not do, NumPy can actually do them. Like in terms of like maybe you want to concatenate or you want to create an array and turn it to a data frame, you could actually use NumPy to do that. So NumPy is much more kind of like a little bit similar to MATLAB. So NumPy actually like does some mathematical operations and some things like creating matrices, creating vectors, and some stuff like that. So it's mostly for mathematical operations. So matplotlib is our plotting tool. So it's one of like the grandfathers of plotting in Python. So they mostly use matplotlib. But for the reason why I won't be using mostly matplotlib to plot, because down I did some exploratory data analysis that I have, and I mostly use Seaborn and not Matplotlib. So Matplotlib, if you want to actually create a plot on Matplotlib, you actually need to write a lot of code. Like you need to write like 5 lines or 6 lines of code just because you want to just do one plot. And that's like worrisome for me because I don't know. Like for me, I like I just like to like just write one line of code and let it just solve my problem for me. Why would I have to write like over 10 lines or 15 lines? And that's even one of the benefits why I even like this library, this Plotly library, because Plotly and Cufflinks, it actually helps you do a little bit of data analysis. That's by doing data visualizations, dynamic data visualizations with just a single line of code. That's one of the greatest benefit of why I even like Plotly and Cufflinks. So this is another plotting I have. So yeah, these warnings is just like maybe if there's any stuff going on, like if there's a depreciation, maybe in one of the modules that we're trying to use, so it hides that warning for us. We don't get to see. Let me run this cell. Good. So now this is the data set I'm going to be using. So I'm going to be making use of this data. So I got the data set from this website. I'll be sharing the link with us after this lecture. So the name of the diabetes is the diabetes data I have, right? So this is the data that I was given. It's not so large. It's very, very small. So this is the data I have. Now, I told us before that this is a classification problem, or no, a supervised learning in terms of machine learning. I will explain. This type that we are seeing here are our labels, and this age is like the attributes of the label that we have itself. So let's say, for instance, someone at the age of 50 and who has a blood sugar in fasting, and they took this sample of who has this blood sugar and this also blood sugar and the plasma glucose test, and is also plasma glucose test, and if he has all these values, this patient actually has type 1 diabetes, right? So if someone has these values, all these values here, this person is normal. If someone also has these values here, this person is type 1. If someone has this set of values here, this person is normal. So let's do this thing in a more mathematical form. So this is like the X, right? This is like the X, and this is like our Y. So this type is like the labels of the data, while all these values here are like the X. So I want to predict the value of Y. So I have to pass in these values of X for me to get Y. So the way it works is this. So when I want to predict or pass in a machine, I want to do machine learning, right? The machine, what it does is that I am going to pass in these values, and I'm going to pass in this value. So it learns from those values that I have passed in. So what I will now do is I will now pass in just this value, and because the machine learning model has learned from those previous data, it is going to predict the value of this, right? So that's what it does. Yeah, so run this. So now the feature information that we're given. So the age, this is just the age of the patients, the BS fast. So this is the blood sugar in fasting before meals, and this is the unit. So we have the blood sugar. This is the blood sugar in 90 minutes after meal. So after taking a meal, they recorded the blood sugar of the patient. So this is plasma R, so plasma glucose test randomly taken at any time. So plasma F is the plasma glucose test fasting, usually taken in the morning because it should be taken after at least 8 hours. So this is a test being carried out on someone, on a diabetic patient, or someone who is said to have diabetes, right? So this value, this particular feature here, we were not provided in the data I was given. There were no information was provided for this particular feature. But I tend to find out that, well, let me just hold on. But I tend to find out that as I was proceeding, I found out that this particular feature is actually very important in our model that we're trying to predict. We'll get there. So df.info, yeah. So in this value that we have now, so df.info is just this.info is the method. So it shows us the features that we have, whether if there's any missing values in our feature, data type each feature represents, and whether if they are complete or something like that. So you can see that so far so good. We have no missing values in the data. And yes, one thing again that I would like to point out is when you are building machine learning models, most times never expect your data to come in this form. Most data will never always come in this form. In fact, you would always definitely have messy data. your data will always be messed up. But because of this is a webinar and I want to waste more time preprocessing data, so I just went online and looked for a website whereby they already have a well preprocessed data that I can just use to give a demonstration about machine learning health, right? So this just gives a description of the data that we're working with. So the features are not much, just 8 columns, and you see that age is actually an integer, which is true. So many of these ones they are floats, and this is an integer, and the type is an object because it's a string, and the class is 0 or 1. So df.describe, what this does is that this just gives us a statistical description of the data we have. So like so far we've seen that the age that we have, the mean of those ages is 11, standard deviation is 11.63, the minimum age there is 21, and the maximum age there is 81. So therefore they did a test on someone who is actually 21 years old, and that was the minimum person there, and the maximum age the test they took was 81. So we could also look at the blood sugar, we could also look at the plasma and the other factors there. So the highest blood sugar recorded was 54.0, and the lowest was 0. So there are some cases whereby someone will not have, yeah. So there are some cases whereby they recorded and they were able to have 0. They were not able to record any blood sugar in someone's blood. So that was remaining for some features. So now we have to do a little bit of data cleaning. Now, data science itself consists of a lot, especially when we are dealing with data. So most times you don't just pass in data you have into a model, especially messy data. You will definitely have an error. Reason is because most times machines are there's a way you have to represent the data you are passing in. There are some algorithms that they don't take in missing values. There are some algorithms that take in missing values. There are some algorithms that you may use and you find out that it's not predicting very well because you've not done so much of data preprocessing, right? You've not done so much of data preprocessing. That's why sometimes you may get wrong predictions. Sometimes it may not even work, and sometimes you just find out that when you try to test the model, you find out that the model does not even try to work at all, right? So now I told us that we are trying to predict type of diabetics. Now the reason why, if you notice here that I actually dropped the class feature. I dropped the class feature, that's this class feature. Reason is because I didn't use it because take an instance now. We found out that those who are normal are not diabetic. Those who are normal are actually not diabetic. Those who are normal are actually not diabetic. So those who have type 1 are definitely diabetic. Those who have type 2 are definitely diabetic. So I want to train my model to, I don't want him to know, because whenever he sees a 1, definitely he knows that, oh, this person is actually diabetic, this person. But I just want to do it in a way that I want to just pass in all these features that are here without the class, and I want it to predict whether this person will actually be diabetic or not, right? So that's why I actually dropped the class feature. So right, so the class is no longer there. So I did a little bit of exploratory data analysis of the plotting. So we can see so far that from this data taken, we're able to see that most people were not actually diabetic. A lot of patients were actually normal. Only and the second people who were much were those who had type 2 and type 1. So far from data collected, a lot of patients were normal and not diabetic, and patients with type 1 diabetic are lesser compared to type 2, which actually makes sense. So we can see that even in real life too, we could actually see that type 1 diabetes is not so common compared to type 2. So those who actually have type 1 diabetes are it's a more severe case than those who have type 2 diabetes. So that's why even in this data that we've seen, we see that it's definitely a normal distribution. Because if you take a normal distribution of people and you start to collect their data, that's randomly, and you begin to collect their data, you will find out that most people that you actually collect their data from, find that most of them will not even have diabetes. Only few of them may actually have diabetes, which is actually true. because in a distribution, if only some certain people have diabetes, then it's no more a normal distribution. It's actually a left distribution or left skewed or a right skewed distribution. So this actually makes a whole lot of sense, really. So yeah, so this is actually a plot of the distribution of the age of people who actually have type 1, normal, and type 2. So we can see that so far, those who actually have type 1 are even within the ages of 0, like this person, like between the ages of 21. We found out that there are just about 5 or 6 of them. Those who are 22, you find out that those who actually have type 1 diabetes, they are not so much compared to normal and type 2. So we can be able to see so far that from this data that we have, when plotting, we can be able to see that even when we plot the distribution of their ages, we can see so far that those who actually have normal, that's those who are highest, are actually within the range. Those who don't have diabetes are within the range of 20 to 23, and they are much. That's in this data collected. They were more than 70, and they did not have diabetes. But we could see so far in type 2 that even people who were at the age of 53, 54, 55, 56, that's they had type 2 diabetes, and even in type 1 diabetes, you still see them here. And even people who were 81, they were not so much compared to other people here. So we could actually see that those who are even younger can even have diabetes, those who are even older can even have diabetes, and those who are even older may not even have diabetes as those who are even younger. So this actually makes a whole lot of sense in your data that you have. So it's from this data that we can be able to draw inferences on whether if even if the, you can even use data exploratory data analysis to test the validity of your data to know whether if your data is actually correct or whether if your data is actually saying what is it to be, right? So these actions, right? So we can see so far that for those who were 21 years old, their blood sugar, the lowest blood sugar there was 0, and the highest blood sugar there was 50, which is mostly an outlier, maybe, right? And for those who were around 65, for those who were around 63, 64, 65, found out that the maximum blood sugar these people have were around 30, 30, let's say 35, 30 to 30, 30 to 35, right? So we can be able to see so far that from this data, based on the age of people have, the age range of people, we can be able to look at their blood sugar. Like, okay, if someone is at 21 years old, chances there are there that he could actually have a higher blood sugar or a low blood sugar. For someone who is let's say 46 or 47, let's say he could definitely have a blood sugar, let's say a maximum, they could have a maximum blood sugar of 30, 30, let's say 30 to 32, let's to 35 or 33, right? And this actually makes sense because I know most people who are actually 21, 22, 23, they tend to eat junk food a lot, right? So there's a higher chance that they will definitely have a higher blood sugar, right? And for those who are actually, let's say 55, 56, 55, 57, let's say the reason why these guys may actually have high blood sugar may be due to alcohol or due to other factors too, maybe hereditary and some other stuff. So we could actually look at some insights from this data that we have that, okay, why do people at the age of 21 to 25 have a definitely skyrocketing high blood sugar? Well, we could look at their eating habits, we could look at some other things too, and from there, the Ministry of Health can decide to take a glimpse at it and try to advise these people that they should stop eating junk food, right? So this is a scatter plot for the data. It's just the same as this one here. It's just a way of saying those who are actually normal. So we can be able to see from this scatter plot that we have that most people are from the data the data that was collected, we able to see that a lot of people actually had normal, that nobody actually have diabetes in this data. We're able to see only few people actually had type 1, only few people actually had type 2, but normal are actually rampant in this data collected. So this is a correlation map, a heat map for short. So it's a way of showing how does one feature relate with another feature. So take for instance, this is the blood sugar. We want to see how does blood sugar correlate with age, and we could see that it's a negative correlation. Correlation just simply means relationship. Like how does age relate with blood sugar? Are we saying that an increase in age gives us an increase in age really gives us an increase in the blood sugar, or an increase in the plasma? Is there a correlation with the plasma and blood sugar? Yeah, you see, there's a kind of like a positive correlation. Sorry, is there a way of plasma that does plasma relate with the age, right? So we could actually see that there is a kind of like a correlation, a positive correlation within the age and the plasma, right? So that's what you could actually see from the data that we've collected so far. So you could actually check it out later on and see some other things there. Yeah, that is a peer plot. Yeah, peer plot is just like seeing. Peer plot is a way of seeing your data at a glance, like plotting all your numerical values at a glance. So let's say you want to see all the data you have generally on just a single, just a plot, just one plot. You could actually do a peer plot. That you want to see how age relates with age. You want to see how age. You want to see the plotting of age and blood sugar. So this is definitely just like a simple plot of how age relates with blood sugar, how age relates with blood sugar that's which was taken between meal intervals and stuff like that. So this gives you a glance of all the plotting itself. So, but I want to like warn you that whenever you are using this sns.peerplot, you try as much as possible because this thing takes a lot of computational power. Because if your data set is very, very large, it takes a lot of time for it to run. It takes a lot of time for it to run. So because this data is not so large, it actually ran faster. So let me just run it. Okay, good. So we can see that it took a lot lesser time because the data we have is not so much. So having doing a lot of some exploratory data analysis in our data, let us look at a little bit of machine learning. Now, still using Python generally, we are going to build a simple machine learning model, right? So these are some of the modules, the libraries are imported. Like I told us before in our uh, in in our slide, like I told us before in our slide, that there are different algorithms you can use. And the best way for you to actually build a good model is to test more than one model. It's not always advisable for you to always rely on just one model. You always try to look at other models too when you're trying to build a machine learning model. So far here I imported like uh over four models. That's random forest, gradient boosting, logistic regression, and logistic regression cross validation, right? So but someone is asking that why what we are doing is a classification problem. Why are we also using logistic regression? Why are we using see there's something they call linear regression and logistic regression. So linear regression deals with continuous variables. There's continuous variables in the sense that you have values that are continuous, like someone's height, someone's weight, like you have something like 1.55, 1.57, 1. That's linear regression. But logistic regression is has to do with it has to do with a fixed value, like yeah, it has to do with something relating to probability. Yes, so it's either you have a probability of 60%. So when it's around 60%, you definitely get a one. So when maybe if it's around lesser than 60%, you definitely get um a maybe it's less than maybe 50 or 40 or 30, you definitely get a zero, maybe a no or a yes, right? That's what logistic regression is, because most people hear the word regression and they think, oh, it's a regression problem. No, you could actually use some of the libraries for logistic regression in a classification problem. Yeah. So let me import the modules. Now, I told us before that when we are training our model, we are going to split it to X and Y. Now, those X are what the machine, like what the model algorithm is learning from, right? So this X here, right? So what we are training our model with is just the age, the BS fast, the BSPP, the plasma R, plasma F, HbA1c. So this is what we are training our model with. And this is what we want our model to predict. So we want our model to predict this, right? So by passing in this. So when our model has this and have this, so when we've trained our model, we are now going to pass in only this, and our model is going to predict just this, right? So let's say I pass in a random value of, let's say, someone's age, someone's blood sugar, someone's his blood sugar, maybe are taken at some intervals, and his plasma, and I pass it to the model. The model can predict to me what kind of diabetic patient he is. Maybe he doesn't have diabetics, or he has a type 1, or he has a type 2, right? So yeah, there's something they call cross validation. So cross validation is a way of validating your model performance. So what it does is that it kind of like splits your data into chunks, like into little chunks, and it tries to train itself with those chunks, whereas with the model that you have used to train, and it now looks out for whether if this model is actually learning or not. So it tries to see and tries to aggregate the total accuracy of that model that you have. So that's just basically what you can basically read on it. That's just like the summary. It's much more, right? So I'm testing different base models. That's why I said that it's not always advisable that one should rely on just one model. One should try different base models whenever he's trying to do any data science project, because you find out that most times it's not even the data itself. Mostly it can be the model. There are some models that can be able to capture some set of data, and there are some models that cannot be able to capture some particular set of data, right? So, right. So this this is going to tell me, it's going to tell me the accuracy of the models I have. That's I'm scoring it with accuracy, right? You can use any metric you want. You could either use F1 score, you could use ROC, you could use AUC. So there are different metrics you could use, but I made use of accuracy, right? So for the logistic regression, we were able to see that it was able to give us a cross validation score of 0.95, which is actually good. Then logistic regression was able to give us 0.99, and random forest classifier was able to give us a perfect score of 1, and graded boosting classifier was able to give us a perfect score of 1, right? So like I said before, this data that I got, it's actually not I think it has been preprocessed already. That's why we are having a very good accuracy like this, because most times when you are working with a large data set, you may not actually have a perfect score of 1, but you could actually have, let's say, something closer to. But this data has been worked upon. That's why it's being biased in a way. That's why we're having an accuracy of 1.0 and 1.0. So after we've already seen the cross validation, let's try to do train, test, split. Now let me explain train, test, and split. So let's say you are given a whole data set, and you want to train the data you have. You want to train the data you have to a model. Now, when you've trained your data, you want to validate the performance of the data you have. So let's say, take for instance now, I want to train 80% of my data that I have into my model. Then I will now take that remaining one I have, which is the test data, and pass it on to the model and see whether if the model can be able to predict the remaining ones accurately. It's just like now you reading for an exam, right? You're reading for an exam. Then in the exam hall, you find out that the answers has already been given to you, even for the answers already been given to you already while you're at the exam hall. That does not make sense, right? So the best way you should just do it is when you go to the exam hall, you have read already, so you have just like a model learning from the data. So after it has learned already, it will now go and validate itself and test itself out whether if it's actually true, whether it's actually predicting very well. So that's what the train, test, split does. So you could actually partition the data. Let's say you could use 80% for training, but it's always advisable to always use a large amount of data for training so that your model can be more robust to predict, right? So you could use 80% for training and 20% for testing, 70% for training and 30% for testing, depending on how your data set is, right? So let me now feature selection. Now, this part is very, very essential, even though most data scientists don't do it. Feature selection is very, very, very important. So, like I said before, that we have like over, let's say we have like over 20,000 features or 30,000 features in our data. We can't necessarily pass all that feature our model. It will not predict very well because there will be so much redundancy in our model because the model will not be able to, because there are some features in our model that affect the value what we are trying to predict, right? That's what feature selection does. So that's what many features. So now something we are going to do, we are going to look at the importance of a feature. Now every feature plays its part on the model, on the prediction that you are trying to predict. Every feature plays an important role. There are some features that you will have that will never play any role in what you are trying to predict. So it's always good to always do feature selection in a way that so that you would know which feature you are supposed to drop and which feature you are supposed to leave for your model to train. Right? So let me run this. Good. So far, we can be able to look at this and we can be able to see that age does not really have much more importance in our feature. Age does not really play a much role in our feature. But plasma R plays a role, blood sugar plays a role, HbA1c plays a role, plasma F plays a role, blood sugar fasting plays a role. But we found out that age here does not really have much importance to our model. And the reason is because I think it actually makes a whole lot of sense. If I want to predict the diabetes of a person, I don't think age would necessarily be a factor that would definitely be right. Like someone could be 15 and be likely to be diabetic. Someone could be 15 and not be diabetic. Someone could be 80 and be diabetic, and someone could be 80 and not be diabetic. So age is not really a factor. But I can say that okay, if the blood sugar is definitely high, there's a higher chance that that person could be diabetic or not, right? So that's this particular features plays a very huge role, right? So let me fit model. Now what I've just done now is I have already trained my model. That was very fast, I know, because the data I have is very, very small and it's not that large. That's why it was able to take seconds for it to work. But when you are employing stuff like deep learning or maybe unsupervised learning, it definitely takes a whole lot of time for you to train your model. Sometimes it can take days, sometimes it can take a lot of hours too. What I just basically do most times is when I'm training models like that, I'll just, if it's in the night, I'll just leave, I'll just go and sleep. Then early in the morning, I'll just come and look at the model. I'll now see the accuracy and the predictions it made. Right. So now after I have already trained my model already, I now want to test my model. Right. So I use the model.predict. So what model.predict does is that it tries to predict the values of y. Like I said earlier before, these values I'm passing here, this x test, right? You can see that this x test just contains only x, right? But I want it to predict y for me. So if I pass in this data, you've noticed that this data is randomized. It's not following a particular order. So I now want to pass this data to the model for me to get whether if this particular patient 801 is diabetic or not, whether if this patient 311 is diabetic or not, whether if this patient 85 is diabetic or not, right? So when I pass the data to this model, it has already made predictions. So if I check Y red, you can see. So it tells me that this person who is actually 801 is likely to be a type 2 diabetic patient. This person with 311 is likely to be a normal, is likely not to have diabetes. This person with 85 is likely not to have diabetes. and this person with this person with 435 is likely to have a type 2 diabetes, right? So you see, based on this data frame I passed to the model was able to give me an array of predictions, right, based on this data I have passed in. So we can be able to see how data science is actually cool. So let's say I have real data, real life data of patients who are actually diabetics, maybe from 1990, let's say from 1990 to date, and I'm able to pass this data to a model, that I can be able to definitely make predictions from this data, and I can be able to see that, okay, without even using inferences, I can be able to just take samples from the laboratory and just use it and just take those values that I've gotten from the laboratory, pass it onto the machine learning model, and the machine learning model can definitely predict whether if this person is diabetic or not, right? That's just what it does. So now that we've um, pass the data to the model, let's try to check the precision and its accuracy. So definitely the model, now this is what it does. Now I told you that we have X train. That told us that we have X train, X test, Y train, Y test. Now these values here, X train is what we are using to train the data, and Y train is what we are using to train the data, right? Now, X test is what you're going to use to validate the data, whether if what is predicting is actually correct. Then Y test is, you have a whole data set altogether, right? So when you split the data and you've gotten your result for the prediction for X test, you will now compare that prediction you've gotten with Y test to see whether if it's correct. So let's say for for X test, the first person here, the first person here, 801, let's say has let me do something. Let's say Y, right? So let's say this person on the norms has type 2. This person has normal. This person is normal. This person has type 1, right? So when I now pass it to the model that predicts X test, it was able to predict those predictions. These particular predictions was what the model was able to predict. And you can be able to see that truly this person was type 2 and is also type 2, which is actually true. The model actually predicted correctly. This is normal and the model predicted normal, which was correct. This is normal and the model predicted normal, which is still correct. So this is type 1 and the model predicted type 1, which is also correct. So when you take a list of that and you pass it to this classification report, so it was able to see that the precision was actually 1, type 1 was 1, type 2 was 1, and the F1 score was actually 1. So we can be able to see that the model was able to predict accurately. That's in the data we have already passed to it, right? Now, so that's just a simple aspect of machine learning. So we've definitely built a machine learning model. So definitely when we can pass in data, we can be able to get a prediction. So let us do something. Now, let's say a doctor took a report from a lab and he wants to see whether if a person is diabetic or not. So let's say the report of the person he took has an age of 20, and let's say his blood sugar was 1.5, and the blood sugar recorded again was 2.0, plasma R, plasma F 8.0, 8.1, and the HbA1c was 45. And I want to now see whether if this person is likely to be diabetic or not. So when I run this model, you can see that it was able to tell me the diabetic type is normal and the confidence score is 68%. Let me explain this. Confidence score is a way to show whether if your model is the prediction that your model is giving you is actually sure of it, and this is mostly a little bit of probability. Let's say take for instance now, you know that you know how 1,000 naira looks like, right? So let's say I show 1,000 naira to you. You can be able to identify vividly that this is 1,000 naira, and you can I am 100% sure that this is 1,000 naira. But if I do the 1,000 naira in a way, maybe it actually fell into soap, then maybe it's kind of like did somehow, or maybe it's bleached in a way, and I show the money to you, you may be doubting that, oh, it could likely be 500, it could likely be 200, or maybe 1,000 naira. So that's what confidence score here does. The confidence score, it tries to tell us, okay, that I am 68% sure that this the diabetic type of this person is normal, right? So let us try another one. So let's say someone is actually 58, and let's say his BS fast was 8.0, and let's say his BSPP was, let's say, 5.5. I'm just guessing really. So let's say his plasma R was 1.2, and plasma F was let's say 4.7, and let's say HB1AC was 6, right? And I run this graph. It actually told me the diabetic type is normal and it had a confidence score of 80. So let me try to play around this a little. So let me increase this to 80. Wow, it still predicted normal. Let me try to look for something. Let me look for someone who has a type 2 diabetes. So let me try this person, right? Uh, right. So there'll be a factor here. So let me change this to 12.6. Let's see. Wow. So you can see definitely plasma actually plays a role in whether if someone can be diabetic or not. So an increase in plasma will definitely mean someone will be that means an increase in this value here will definitely mean that it's likely that person could be diabetic. So you can see the model predicted type 2 and it gave a confidence score of 54%. That means he is 54% sure that this person is a type 2 diabetic patient, right? So definitely then the more inferences can be done to see whether if it's actually true or not. So this is how machine learning can play a role in such a way that it can save human little bit of it can save human stress of being able to do so much. I can be able to do so little and can be able to achieve so much with just machine learning. So that's a simple breakdown of what we could actually use machine learning to do. Apart from just this, even in other health stuff too, whereby you could try to predict whether if someone has a lung cancer or not. You could actually take so many pictures of people who actually have lung cancer and train that pictures to a machine learning model, and the model can learn from those pictures, and when you pass it a new set of data, it can be able to predict whether if this person has lung cancer or not. So in the case of this COVID-19 going on, just like I've explained, people are trying to forecast. So they're trying to forecast based on previous data they've collected on the coronavirus case, right? And they can be able to see that with this forecasting they've made, they can be able to forecast into the future and see whether if someone has diabetes or not, right? So that's just basically what we can do. So this is just a little bit of explanation. This is just a tip of what machine learning can do. Basically, machine learning is much more broader and much more bigger than this. I just want to show us a glimpse of how we could actually apply machine learning in areas such as health today, right? So after that, let's say I am a data scientist and I have finished doing my work. I want to deploy my model. Like for me, I always like that's the part I always like very well. I like to always deploy models. That's part of data science I like. So after you finish making your testing your model and you see that your model is actually good, you could now deploy your model to a server or to production, either by using Django, or you can use Flask, you can use Microsoft Azure, you can use Google, you can use TensorFlow. Yeah, you can use TensorFlow. You could also use Google Cloud also. That's Microsoft
Yes.
Firebase also. Yeah, to uh, do that. So yeah, so about how that's definitely what we can definitely do with machine learning. Yeah, so thank you very much. So any questions?
Great, 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 great.
So
Wow, that's very nice. We have a question here.
Okay.
Sorry, yeah, we have a question
Who
here,
is clapping?
and, and you can even hear the background. I mean, people are clapping for you. I mean, it's been a very brilliant session. In fact, I myself, I myself, I've been able to learn something from this. So I mean,
That's cool.
let's
That's cool.
let's just start, let's just start from the last one there. Someone just
Okay.
says that he would like to be like you. In fact, that someone is commenting that he would like to be like you, and yeah. He says he loves the way you use feature selection and Seaborn. So he just loves it, you know.
Okay.
And
Okay. That's good.
someone
That's
else
good.
is asking, yeah, someone else is asking, will this be available on GitHub? The
Yeah,
lecture?
sure, sure. Definitely. Definitely. Yes, it will be. Yes.
Yeah, would it?
Yes.
Okay, we'll definitely pass to the participants. And we also have another question. Someone says, he says his question is not really ML, but he's talking
Okay.
about using pandas. Using pandas. He said
Okay.
using pandas, you can't view all your data sets. He says he has a data
Yes.
set with lots of rows. He says he has a data set of rows and column, and he would like to
Okay.
make some visual with the data, but he can't view all his data. So he's
Okay.
asking why.
Okay. There's a way. The reason why you can't view all your data on Pandas is because, when you try to load your data to a notebook, it uses a lot of processing power on your computer. So it's not always advisable to actually load all your data. As a result, that it could hang your system. That's unless if you are using a GPU or a TPU system, right? So that's why Pandas won't allow you to see all your data. So pandas can only show you a portion of the data that you have. But there is a feature in pandas that can even allow you to see everything. But that is actually at your own risk though. But what you could actually do is there's actually a syntax you could use whereby you could actually view more rows and more columns in your data. You just have to use the set option. That's when you import pandas as PD, just use pd.set option. Then you can set the maximum rows you want to see, then the maximum columns you want to see. Yeah, you can definitely do that.
Great, great, great. Once again, let's know that this session is recorded, and we'll try as much as possible to make the video, the slide, and everything available to you. We'll share them across emails and the likes. Okay. Now, someone also said something. He said you said this is multi-class. Where is type 2 diabetes? You have only normal and type 1. That was in the course of
No,
the training.
had type 2. Let me show you. Um, okay, type. So, can you see? I definitely have type 2. I definitely have normal. I definitely have type 1. So there's no how I would want to it will not even work safe. So you must have those data. Type 2 is there, type 1 is there, and normal is actually.
Okay, okay.
Oh,
It's
okay.
okay now.
Okay, I think he just responded. All right. So someone is asking, is matplotlib worrisome? Hello? Yeah, so someone was asking, is matplotlib worrisome?
If you know fathers of plotting, so they don't allow you to like just plot with just one line. If you want to just make a single plot, you have to like write like up to 6 lines or 7 lines, depending on how you want to make your plot. So you that's for interactive plotting.
Okay. Okay, hello? All right. Hello? We have two questions here concerning deploying your model. So well, we have two questions here on deploying your model. So someone is asking, are you going to touch the deployment aspect of the lecture? So could you just answer that? And someone else is asking can you quickly share your screen again on deploying your model? Hello, can anybody hear me?
Yes, I'm here.
All right.
Solomon is here. Hello.
Israel. Okay. Yes. So, all right. So someone again is asking, can you share your screen again on the your model? All right. So while we are waiting for Israel Aminu to come up with that, let's just so would like to inform everyone that our next webinar will be next week Tuesday. That is around 4 p.m. Nigerian time. Our next webinar will be next week Tuesday, 4 p.m. Nigerian time, and we'll be having Rachel Lund, who'll be taking a session from the UK. And so we can just and again, he spoke about Israel Aminu spoke about using Plotly, using Plotly, cufflinks, and Dash and the likes of it. So Rachel launch session will majorly focus on building interactive dashboards with Python. So I think it's a session that you shouldn't miss. You should invite your friends and your colleagues around 4 p.m.
Hello, can you
Nigerian
hear
time
me?
next week Tuesday. Yeah, we can hear you now. Okay, we have you back.
Okay, good.
Yeah, we
Sorry,
can hear you.
can you repeat the questions?
All right. Now, so
Yeah.
the question was, it was talking about, are you going to touch the deployment aspect of the webinar, deployment aspect of the
No,
model?
no, 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 no. If you want to deploy your model, it's actually easy, not hard. So you can actually use Flask or Django to deploy your model. So I wrote an article on how you can deploy your model via an API using Django. So I would post that along too with the link. So you could also check it out. It's very easy and straightforward too.
Okay, great. Okay, somebody's asking, how can I get started and be like him from the scratch? All right. All right. I think we can just choose something in. As we one of the things we are trying to do from the community, from the Reispar Analytics community, is
Okay.
to build and encourage an ecosystem around data science and emerging technologies. And like I said, we have an upcoming webinar again next week Tuesday. So these are sessions
Okay.
that you can use to practice. And then we also we have a paid session. That's for those who want to go into business intelligence. You want to do a bit about SQL for data analytics. You want to go into Microsoft Power BI. That will be starting next week Tuesday, and is discounted at 25,000 naira for the session for 5 days. So we have these and many more. This is a paid session. We have these and other free sessions will be coming up from next week, and you can always sign up on that. But Asia, you can also add one or two things about how you started as well too.
Um, okay, yeah, pertaining to that question, right? So the thing there is, data science is you have to just have a flair for it, really. It's a very interesting field, and it's in fact I've always like it's a field that I always want to enjoy mostly. So to just get started, really, one just need to like learn the basics of Python, then just like that chat you must knowledge about, then a little bit of computer science, then just try to do a little bit of projects, yes, and try to take part in competitions like cargo and if possible, join forums or join other communities too, where they try to share some things about data science, because as you are reading them, even though you don't even know what they are saying, but as time goes on, it will begin to make sense later on. So I think that's what you should just do. But the major idea there is like you should try to understand, try to get a little bit of the foundation first, like understanding the concepts, understanding this thing. There are so many courses online you could even use, you could even take part in, that would even definitely help you along the line.
Yeah, that's very great. And in fact, talking about communities, one of the things that we are striving with, that we're currently doing right now at Reispar Analytics Academy, is to build a community. And if you check the chat area, you can see we dropped some links. We dropped some links. We have one. We have the Microsoft Power BI group, which we recently started up. And so, in case for those who want to grow, they want to grow their area, their skill expertise in terms of Microsoft Power BI, using interactive dashboard, you're welcome to join this group. We're going to be having meetups. We're going to be having different things. You can post your questions there on the forum. This forum is being backed up by it's a Microsoft backed up community, and so there are several other ones. We also have Open Data Science conference, which started last year, which we were able to bring last year to Nigeria, and that's for that. So, and like I said initially, we have some paid sessions as well. We have some paid sessions. We have one which will be starting next week, Tuesday. That's the BI class. And after that, again, we also have on Tuesday. Again, we also have a free session for 4 p.m. where Rachel will be coming to take that session, and that. So, do you have? If there are any other questions, kindly drop them in the chat area. So while we're waiting for any question, I want to, on behalf of my team, and we want to rather appreciate everyone for joining us today. We have people coming from Kaduna, people from Abuja, people from Ogun State, people from Lagos, Ibadan, Ilorin. I mean, it's been an awesome time learning from Israel Aminu, and I mean, it's been a very great one. And we know that we're going to have you back again on Tuesday for our next session.
Sure.
And yeah, thank you for coming. Israel, one more parting word from you.
Yeah, I want to say you can definitely reach out to me on Twitter or LinkedIn. So if you have any question, or you are confused about, or if you are confused about something, you just send me a message on Twitter, or if you just send me a message on LinkedIn. I will definitely just get back to you. But for this class, I will send it. I will send it on GitHub 10 minutes from now.
All right. So once we have the link, we'll forward it to the participant. I think we all have your email address and everything, so you should get to see that soonest. Okay. So if there will be no further questions, thank you once again for coming, and would also ensure that we'll release the recording as well too in a couple of days. All right. Thank you for coming. We appreciate you. Thank you, and see you next week Tuesday.